is very useful for us to actually get messages from our code back into this really cool little section down here, logcats, which allows you to actually run. It's sort of a console-like way of actually being able to look at errors from your activity. In fact, you can see it says this is an error which masks or which replicates what we see here. This is very good for debugging in the Android world. But if I actually run this code, this is what we would see. So very much like in Xcode, how you have an emulator for iOS, do you have an emulator for Android devices as well? So what's cool about this is that this is actually an emulated Android device, and so I can go to the, oh, I can't see the, we've been bitten by the resolution bug. There's some buttons down here that allow me to go to the home screen, and we can sort of play around with this version of the Android device. Unfortunately, it's cut off. So rest assured, it's there. You can click on it, but not right now. But what this allows us to see is our Hello World application. We have here our activity, which takes up the entirety of the screen. By default, the theme was black. We didn't get to see that, but it's elsewhere actually within the package itself. We have our one text view. It says our text, and that's about it. Up here, this is just the title bar for the application itself. It's a little confusing at first when you expect to only see this, and you also see the title of the application, but realize that that is actually just the Android OS displaying a little title above the application itself. We could give a flag in the manifest that would request that this activity become full screen and hide everything, but we haven't set that flag. We've just done a very simple manifest file here. Then, of course, we have our system-wide status bar at the very top here. Now, there's a few other things that I want to show you about this. I'm going to make a few of these activities available in the source code for you to download and actually play around with. We don't really have a lot of time to go through them, but hopefully if you just go through them one at a time, they will progress in such a way that you will be able to hopefully start following along as we make slightly more complicated layouts, start adding second activities, and start doing other things with the Android OS. But there's a couple of things that I want to point out about the SDK itself. One of them is that this IDE, again, is Eclipse. This is not written by Google, but in fact is a larger open source project. If you already have Eclipse, download it because you do development in other languages, or even in Java. You can actually download the SDK without including the IDE itself. You can just download the SDK, the plugin, and follow some steps on the developer website to get all of that working in your own version of Eclipse that you might have already installed. But if you don't have it installed already, don't worry about it. You can just download everything and have it work out of the box. Once you have everything set up, though, if you go to this menu, the window menu, you'll notice that you have a couple of new Android options. And I'll zoom in here so that you can see them. You have Android SDK Manager, Android Virtual Device Manager, and Android Lint, which is a checker. But it's these two that we are worried about now, the SDK Manager and the Virtual Device Manager. The SDK Manager allows you to download different versions of the SDK. So if you want to build an application against a specific API number, you have to make sure that you have downloaded that SDK. So if you download all of this, this is going to take up a lot of space. It's several gigabytes worth of information that has to be downloaded onto your computer. But then you could compile your application against any one of these API targets, and it will work just fine. In this case, because I had set in the manifest file, the minimum SDK version, of 3, as we can see here, I have to make sure that I, in fact, have that version installed. And as you can see, Android 1.5, which is an API level of 3. So realize that there's two different versions. The public-facing version is the string Android 1.5, but the API level is an always incrementing integer, which started at 1. Basically, the earliest version that was released to consumers was API level 3. And it just has been going up ever since then. So here we can see that I, in fact, have the SDK platform and the APIs installed. You can do that on your own for whatever version you want to run. But the more fun one, I would say, is the Virtual Device Manager, which allows you to create virtual devices, emulated devices, in just about any configuration that you can imagine. So if we were to create a new device here, what this is going to allow us to do is to create a new emulator of sorts that replicates certain features of a device. So we can specify a variety of things. We can give it a name, so I'll just say Android 2.4, just for example. Now we can see here that when I click on device, we have a list of different device sizes. Pick your poison that goes all the way from the Nexus 10, which has an enormous 10-inch screen, all the way down to some of the earliest Android devices, including a 240 by 320 screen, which is pretty small. We can select any of these and actually create an emulator so that you can actually test your application across a wide variety of devices before you even release it to the Google Play Store. I'm just going to, for fun, select the Nexus 10. I can select the target. So this is the API. This is basically the OS version that this should run, that this hardware device should run. Now, it is possible for you to get yourself into trouble here and run an ancient version of a target on a new device that would not ever have that installed. So you have to sort of be careful here that you select ones that would make sense for that. Sometimes you get the ability to change the CPU if there is, in fact, an option between ARM and Intel. Hardware keyboard would be emulating an actual hardware keyboard on this device. Hopefully the rest are somewhat self-explanatory. You would get to set things like the RAM size, the amount of heap that your virtual machine would have for this application, the amount of internal storage, if that device actually has to emulate an SD card. And notice a couple of options down here. Snapshot, which if you've used virtualization software elsewhere, like VMware or Parallels or any sort of thing, when you actually close that virtualized window, it saves the state of the memory and will allow you to restart it from there. Similar thing here with Snapshot. You can actually save the state between times that you close and then reopen the emulator, which is pretty good because sometimes it takes a while for these emulators to load. And they now have also hardware accelerated GPU, which is great because before it was software and it was just the worst. It was so slow. Okay, so you can create one of these and you can have actually a variety of them. Now, in order for you to test your application on an emulated device, you have to first, here's the steps, make sure that you download, make sure that you download the appropriate SDK in the SDK manager, and then create a virtual device in the virtual device manager. Then you have an emulator that you can actually run. So in this case, I actually have my Android 2.3.3 running, as you can see right here. So I'm emulating an Android 2.3.3 device in this emulator. Now, there's a couple more things I want to point out. One of them is that there's this number to the left of the name, 5554. Now, this is pretty cool. What this allows us to do is to log in to the emulated device from our computer. So in this case, I can open up a terminal window, type in telnet localhost, and then that port number, that number actually coincides with the port that's running within our computer or within the emulator and is exposed through our computer. When I hit enter, notice that I connect to this emulator. This is something that you can really only do through the emulated devices. Now you can type help, and you actually get a variety of things that you can do. So you can actually force the emulator to change its state in a variety of interesting ways. You can have, for example, it follow a set of geo tracks. So maybe your application is actually really dependent on geolocation, so you could actually provide it some geo tracks and observe how your application reacts as the phone is not taken in a physical sense, but is taken in an emulated sense through that geolocation track. You can also do a variety of things like what happens when I change the network settings on it and say the user loses cell phone signal and they only have Wi-Fi, or vice versa. How does my application actually react to any of this, to all of these sorts of things? You can also send the emulator an SMS, which is pretty funny. But it is actually useful, especially if you are creating an application that is relevant to that, and a variety of other things, as you can see here. Now, one of the really neat things here is that if you have an Android device and you are doing Android development, you can plug in that device using USB to your computer, and you will be able to develop directly onto that device. You might actually have to check a few settings in the developer menu that says allow development mode and some other things. But what this essentially allows you to do, really without having to deal with any certificates or anything like that, is that you can very quickly and easily connect an Android device to your computer and try your program not only on an emulated virtual device, but also on your physical phone or physical tablet as well. And can you also connect to it and run a variety of commands. It's really limited in these physical devices because you don't have root access to the file system unless you have actually rooted the device, which is an entirely different issue. But even though that is an option, it's probably better to test this out on an emulated device and then see how it behaves on the physical one. But that is certainly an option for you there as well. And one of the great things about the Android SDK, very much like the iOS development in Xcode, is that once you understand some of these simple principles, once you understand Java, once you understand how an APK is built and what its hierarchy of files actually looks like, it becomes very easy for you to look up the APIs that are given to you in the API documentation and quickly make an application that you would want to run or that you would want to deploy to users. And so hopefully then this has been a good summary of how you can actually get started with it. So if you are interested in this, go ahead and go to the developer website, download the SDK, and get started on Android development. And until then, I want to thank you very much. I think David has a couple of last words, but thank you all for your time.
Hopefully linger for a couple minutes for one-on-one questions. Otherwise, we posted all resources from tonight on the course's website. On Wednesday, Chris and the team are going to dive into some more advanced iOS topics. Next Wednesday, we will gather for one last time for Cake and Apps, so we will see you then.